Today's lesson is about rectangles, rhombi, and squares. Rectangles are a shape you're probably pretty familiar with. A rectangle is a quadrilateral with 4 right angles. A rectangle has all the properties of a parallelogram. So we know the opposite sides are parallel, the opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, the diagonals bisect each other, but for rectangles, we can add 2 other properties that the other parallelograms do not necessarily have, which is all 4 angles are right angles and the diagonals are congruent, okay? So we have some practice problems involving rectangles down here. It says quadrilateral ABCD is a rectangle. And we're supposed to use this picture for each of these problems over here. So I'm going to have to kind of erase and write over them as we move from problem to problem. But for problem number 1, it says AE is 36. So from A to E right here is 36. And CE is 2x minus 4. So right here is 2x minus 4. Find x. Well, the diagonals of a rectangle bisect each other just like they did on the parallelogram. So that means 36 would have to equal 2x minus 4. So to solve for x, we start by adding 4 to both sides of the equation. So 40 equals 2x. And then we have to divide by 2 on both sides of the equation. So x is equal to 20. And that one is done. So I'm going to erase this and we'll move on to the next problem, number 3. It says if BC is equal to 24, so that's the top, BC is 24. And AD is 5y minus 1, so that's the bottom, 5y minus 1. Find y. Well, we know that the opposite sides are congruent on a rectangle, so we can write an equation for number 3. 5y minus 1 equals 24. So we're going to start by adding 1 to both sides to get that 5y by itself. So 5y equals 25. And then we have to divide by 5 on both sides. So y equals 5. And that is all we have to do there. So moving on to the next problem. Let's see if I can get all this in here at once. Number 5, it says, if the measure of angle AED is 12x, and the measure of angle BEC is 10x plus 20, find the measure of angle AED. So this is going to be a 2-step problem because first we'll solve for x, then we'll have to plug x in to find the measure of angle AED. So notice these 2 angles are vertical angles, and vertical angles are congruent. So 10x plus 20 has to equal 12x. Now we want to get the x's together on the same side of the equation. So we're going to subtract 10x from both sides. So 20 equals 2x. And then we're going to divide both sides by 2. So x is equal to 10. But that's not the answer to the problem because they wanted us to find the measure of angle AED. And the measure of angle AED is 12 times x. So we're going to go 12 times 10, which will give us 120 degrees for the answer. Okay, number 6. Let's see. it says if BD is equal to 8y minus 4, so that's this diagonal, BD, 8y minus 4, and AC, this diagonal, is 7y plus 3, find the length of BD. Well, for this problem, we have to remember our new rule that the diagonals of a rectangle are congruent. So that means 8y minus 4 would have to equal 7y plus 3. So to solve for y, we'll subtract 7y on both sides. So y minus 4 will equal 3. And then if we add 4 to both sides, we get y equals 7. But that's not the answer because they want us to find the length of BD. BD is equal to 8 times y, which we now know y is 7, minus 4. So 8 times 7 is 56, and 56 minus 4 is 52. So the answer is 52. Okay, the next problems we're going to do, we're going to need to use some graph paper for it. The directions here say, let's see if I can get it situated. There we go. Graph each quadrilateral with the given vertices. Determine whether the figure is a rectangle. Justify your answer using the indicated formula. Okay? So I wrote down these points on this graph paper. So we'll start by plotting them. X goes first, then y, so we'll go along the x-axis first and then the y-axis. So -3, 1, 2, 3, +1. Here's point A. And then we have -3, +3. So there's point B. And then we have 3, 3, there's point C, and 3, 1, there's point D. So here's our shape. What do you think? Do you think it's a rectangle? I think it looks like it could be. How do we know for sure? Using the distance formula. That's the formula they want us to use. Well, remember that on a rectangle, the diagonals are congruent. So if we find the lengths of the diagonals, we can compare those, and if they are the same, then we will know we are looking at a rectangle. So let's start with the diagonal from B to D, okay? Point B is at -3, 3, and D is at 3, 1. So we'll call it x1, y1, x2, y2. And we'll find the distance BD by filling the numbers into the distance formula where they go, starting with x2. 3 minus x1, -3, close parentheses squared, plus new parentheses y1, y2, which is 1, minus y1, which is 3, close parentheses squared. We can use a calculator to find the answer. Second square root, parentheses, 3 minus -3, close parentheses squared, plus new parentheses, 1 minus 3, close parentheses squared. So this gives us 6.32. BD equals 6.32. Now, let's find out if the other diagonal is congruent from A to C. So AC, and we'll label them X1, Y1, X2, Y2. So we're going to put it in the distance formula, starting with X2, 3 minus negative 3, close parentheses squared, plus y2, which is 3, minus y1, which is 1, close parentheses squared. And keep in mind, this distance formula is on your formula chart, so you don't have to have it memorized. You're allowed to use it on your quizzes and your tests. So we'll type this in to our calculator to see what this equals. And it gives us 6.32. They are the same. So we can say this is a rectangle. We use the distance formula to determine that the diagonals are congruent. All right, next, we're going to determine if this one is a rectangle using the slope formula, okay? So let's start by plotting the 4 points on the graph. Okay, negative 3, 0, negative 2, 3, 4, 1, 2, 3, 4, 5, and 3, 2. What do you think? Do you think it looks like a rectangle? Well, on a rectangle, the slopes of the consecutive sides should be opposite reciprocals of each other. So if I take any two sides and find their slopes, and they are touching sides, then their slopes should be opposite reciprocals if they make a 90-degree angle, so they're perpendicular lines. So let's see, this is A, B, C, and D. Let's find the slope of the line AB first. So A is at negative 3, 0, and B is at negative 2, 3. X1, Y1, X2, Y2. So AB, the slope would be y2, which is 3, minus y1, which is 0, divided by x2, which is negative 2, minus x1, which is negative 3. So that's 3 divided by 1. Now let's look at BC, because this one touches this one, to see if they're perpendicular. For BC, point B is at negative 2, 3. C is at 4, 5. So this is x1, y1, x2, y2. So we'll start with y2, which is 5, minus y1, which is 3. x2 is 4, minus x1 is negative 2. 5 minus 3 is 2, and 4 minus negative 2 is 6. That simplifies to 1/3. Notice these slopes are reciprocals, but they are not opposite signs. So if the slopes are not opposite reciprocals, that means the sides are not perpendicular. Scoot it down. Perpendicular. Okay, so this one is not a rectangle. If we would have gotten the second one to be negative 1/3, then it would have been a rectangle, and we could have said it was by using those slopes. Okay? All right. The next thing that we're going to talk about is rhombi and squares. So, what is a rhombus? Do y'all know what a rhombus is? A rhombus is a quadrilateral with 4 congruent sides. Opposite sides are congruent, so a rhombus is also a parallelogram and has all the properties of a parallelogram. But rhombi also have the following properties. The diagonals are perpendicular. So they cross at a 90-degree angle when you draw the diagonals. And each diagonal bisects a pair of opposite angles. So if you look at the diagonals drawn on the picture, these angles are the same, these angles are the same, these angles are the same, and these angles are the same. All right, so let's use that information. Oh, and I almost skipped over the square. A square is a parallelogram with 4 congruent sides and 4 congruent angles. A square is both a rectangle and a rhombus. Therefore, all the properties of parallelograms, rectangles, and rhombi apply to squares. So squares are super special because all the rules and all the properties that we've learned about your rectangles, your rhombi, and parallelograms in general will apply to squares. Okay, so we're going to use this picture here to answer these questions. Quadrilateral ABCD is a rhombus. Find each value or measure. Number 1. If the measure of angle ABD is 60, find the measure of angle BDC. Well, this angle is going to be congruent to this one, and this one, and this one. So the measure of angle BDC should be 60 degrees. If AE is equal to 8, find AC. So AE is only halfway across, AC goes all the way across, and since the diagonals bisect each other, this side should also be 8. So to find AC, you just do 8 plus 8, which is 16. Okay, then it says find the measure of angle CEB. Remember that the diagonals of a rhombus are perpendicular. So this angle at E, actually all 4 angles at E, are 90-degree angles. Okay, now I need to erase to do the last one here. If AE is equal to 3x minus 1, and AC is equal to 16, find x. Okay, keep in mind AC is all the way across and it's 16. AE is only halfway across, so it would be half of 16, and half of 16 is 8. So 3x minus 1 would equal 8. So to solve for x, we will add 1 to both sides. So 3x equals 9. Then divide by 3 on both sides, so x is equal to 3. All right, last one. AD is 2x plus 4, and CD is 4x minus 4. Find x. All right, this is a rhombus, and on a rhombus, all 4 sides are the same, so these sides are congruent. So we can write the equation 2x plus 4 equals 4x minus 4. And now to get the x's together, I'll subtract 2x on both sides of the equation. So 4 equals 2x minus 4. And then I'm going to add 4 to both sides of the equation. So 8 is equal to 2x. Then I divide by 2 on both sides. So x is equal to 4. And that one is done. All right, we just have 3 more problems to do. And on these problems, it says, graph each set of vertices. Determine whether the parallelogram ABCD is a rhombus, a rectangle, or a square. List all that apply. All that apply means it could be more than one of those shapes, so if it is, we need to tell them. And we're going to do these 3 problems, and I've written the coordinates down on my graph paper. So let's start with this one, number 1. We'll plot the points. 0, 2 is A, B is at 2, 4, C is at 4, 2, and D is at 2, 0. Whoops, I wrote 4 instead of B. Silly me. All right, what do you think? Rectangle, rhombus, square, what is it? Well, let's see. If I look at the slope of this side, it's rise 1, run 1, rise 1, run 1. And if I look at the slope of the next one, it's down 1 over 1, down 1 over 1. So if this has a slope equal to 1 over 1, and this has a slope equal to negative 1 over 1, those are opposite reciprocals, so this is a 90-degree angle. And remember, we had a rule that if a parallelogram has one 90-degree angle, it has 4 90-degree angles. So this is definitely a rectangle because it has all angles the same. They are all right angles. Now, what about a rhombus? Oh, I'll write this down. It's a rectangle because all the angles are 90s. What about a rhombus? Is it a rhombus? Are all the sides congruent? Well, are the diagonals perpendicular? I believe so. This is 4, and this is 4 also. The diagonals are congruent. They also intersect at a 90-degree angle right here in the middle because this one is vertical and this one is horizontal. So we are dealing with a rhombus. Also, if you did on these right triangles, 2 squared plus 2 squared would equal 8, and the square root of 8 would be the length of this diagonal. So that's going to be the same length on each one of the 4 sides as well. If a parallelogram is both a rectangle and a rhombus, it is a square, because a square is a parallelogram with 4 right angles and 4 congruent sides. So this one is all 3. All right, let's look at the next one. -2, -1 is point A. 0, 2 is point B. 2, -1 is point C. And 0, -4 is point D. Scoot that down a little bit. So what do you think about this one? What is this shape? Well, I'm looking at these diagonals. They look pretty perpendicular to me. And it looks like each one has a leg of 3 and a leg of 2. So if you were to use the Pythagorean theorem to find your missing side, these would all be congruent as well. These are not 90-degree angles in the corner, so I would not call it a rectangle or a square. This one is a rhombus. Okay, and now here's the last one. -3, 0 for A. -1, 3 for B. 1, 2, 3, 4, 5, down 1 for C. And 3, -4 for D. What do you think about this one? I don't think it's a square or rhombus because the sides don't look the same lengths. But maybe it's a rectangle. Let's find the slopes of 2 consecutive sides. This one is rise 3, run 2 for the slope. And this one is down 1, 2, 3, 4. To the right, 1, 2, 3, 4, 5, 6. Down 4, right 6. That fraction simplifies to -2/3. Notice opposite signs, reciprocals, they are perpendicular. So this is a rectangle. Okay, I hope you had fun learning about rectangles, rhombi, and squares today. Good luck with your assignment. Please let me know if you have any questions or if you need any help at all. Have a great day. Bye.